Contractors for primitive equations. What is a primitive equation? Z equal x plus y is a primitive equation. Z equal x times y is a primitive equation. Y equal to the sine of x, y equal to the exponential of x, and so on, are primitive equation. In fact, a primitive equation is an equation that cannot be decomposed. For instance, if I take this one, exponential of x plus square x, this equation can be decomposed as follows. A equal to a plus b, with a equal b equal a equal to exponential of x and b equal to the square of x. These three equations are primitive equations, but this one is not a primitive equation because it can be decomposed. Not this one. The idea to compute primitive equation is almost always the same. We take the variable, we isolate them, and we use the interval computation to compute the optimal contractor. Consider, for instance, this equation. Y is the exponential of x. I have here x and y. I have here my equation, exponential. The contractor corresponds to this. It takes a box as an input, this box as an interval component for x, but also for y. And the optimal contractor amounts to compute this box. Let us apply the principle explained before to compute this optimal contractor. Cx contraction for x has two inputs, x and y. The corresponding algorithm will be the following. Y equal to y intersected with the exponential of x. If I do this, I will compute the exponential of x, which will correspond here to this and this. This corresponds to this. I will compute this intersection and I will return this one. It is the forward contraction because I go from the input to the output of the function exp. Forward. And the contraction is like this. Once I have contracted x, y, I will contract x as follows. X equal to x intersected with, recall that I have to isolate x equal to the logarithm of y. And if I apply this, I will compute the logarithm and I will obtain the image, the reciprocal image of this interval will be this interval, and the intersection will provide me this interval. Again, I have to use interval arithmetic to compute the exponential and the logarithm of the interval, and applying twice these two operations, twice interval arithmetic, then I will obtain the optimal contractor.